All right, we're just gonna get started up here and make sure I'm good, and we'll get going here. Health is good. All right, good morning, everybody. Welcome to ChrisKonkleVlogs live stream. Today I'm going to be talking about new building materials, the high-tech 2018 edition. I got a bunch of cool websites lined up again. Like I have until we start getting a bigger audience here, ChrisKonkleVlogs at live stream. I'm just going to go over the websites that I find for you guys. You guys know the links are down below, so you can follow along. If you're watching on the replay, you can check out those links anytime. All right, so let's jump right into it. This first website I picked was it's on the different materials like concrete and insulation and the actual new gypsum type of board and wall board. So some cool things happening. You guys know that LEED is getting to be quite a huge thing. So the green building products are very well sought out, and people and contractors, where everybody, architects, designers, everyone is starting to think now, right from when the product comes out of the ground to the installation of the building, and then of course when the building needs to be taken down and replaced or whatever, right? So they have all these things that they take into consideration up front now. So that's really cool. So concrete is huge, right? So this article here starts off with, while cork flooring and bamboo furniture gets all the attention in green homes, eco substitutes for old school construction products like concrete, lumber, and insulation are where the real action is, which is really neat, right? So you can see right now, one of the articles I found was this green building material industry is at around 380 million a year, and it's going to grow 25% over the next 5 years, 571 billion. Oh, sorry, it was 370 billion, and then it was like 380 billion actually. So 571 billion in sales. That's a lot of dough, right? So it's really cool. You can tell there's a lot of investment in this area for research and development, right? So some of the cool companies, like this one right here, it's in California, Serious Materials. They have like who's this high insulating windows and eco replacement for drywall, right? These are the guys who have the drywall. So the agency Energy Star requirements, these windows are like 4 times that, and will reduce your utility bills by 40%. That's huge, right? So the Eco Rock is made from 80% recycled materials, including waste from steel and cement plants. So that's requires just 1/5 the energy to produce as conventional drywall. So that's pretty neat, pretty cool, right? So I know, trust me, I'm a drywaller. I've done a lot of it, and it's heavy, dirty stuff, and yeah. So if this can even make it lighter, we're laughing, right? So the lighter the better. Oh gosh. So I create another concrete. So which one? This one? These guys do started to shake up the industry. The company says it will develop what it calls a mixed design technology that leads to a higher performing and more economical and environmentally friendly. Using the construction of New York's Freedom Tower, the high concrete can reduce the overall carbon footprint of construction project by 40%. That's huge. That's huge, right? So Highcrete is taking a different approach. Oh right, yes. So they'll develop a chemical that makes the concrete waterproof, right? So concrete walls that are underground, like those for basements or parking structures, traditionally are protected with a plastic membrane so water from the surrounding soil doesn't cause damage. The use of Highcrete's admixture removes the need for petroleum-based membranes, speeds up the construction process, and makes concrete buildings last longer while cutting fossil fuel use. That's really huge, actually. Not having to use a petroleum-based product, those membranes are, the torch-on stuff or the heavy mastic you got to apply. It's all just gross, nasty, gross stuff. So I think that's amazing not to have to use that. It's really cool. So yeah, anyway, so this guy's, oh yeah, these guys are here too, right? They got a new brick. And it's architectural face brick that's made with fly ash, a byproduct of coal burning power plants, and generate about 90% less carbon dioxide in their production than conventional clay bricks, right? So that's the thing, right? With these green and high tech materials, we're always trying to find how to recycle, right? To reuse the waste products, right? And coal, like I can't even believe that there's still coal burning power plants out there. That's that's kind of strange to me. I mean, they're got to be so old and pollute like crazy, right? I don't know. I'm not sure. Anyone in the chat know anything about you know what were we just talking about? Oh God. Oh, coal burning power plants. It just seems like they'd be outdated, right? I don't know if anyone knows anything about that, but let us know. Aspen aerogels. Oh, this stuff is really neat. So may take the prize when it comes to the nexus of sophisticated technology and the building industry. The Northborough, Mass-based nanotech startup has developed a way to mass produce aerogels, gels with high air content that are one of the most effective insulating materials in the world. So all of that air means the material is extremely light, and that has caught the attention of industries as diverse as national defense and outdoor gear and apparel. So yeah, you know, like it's pretty neat, right? So you guys can come back and check out these different products whenever you want. The link is right down below. This next one here, we're not going to go through the whole thing, but ETFE, right, is some kind of, it's like this glass stuff, right? So this little article here is 70 pages long. It's in the LinkedIn slideshow. You can actually download it, which I did, but it goes over the different types of glass, right? So alkali fused at high temperature is one of the most widely used construction materials. Fused at high temperatures, right? It's composed of silicates, and an alkali fused at high temperatures has been one of the most widely used. Yeah, so Crystal Palace, wow, 1851, wow. So for iron and glass, so this is like about glass, like this is cool. I love this. So photochromic glass responds to light, thermochromic glass responds to heat, electrochromic technology changes the transparency of glass partitions or cladding from clear to opaque by passing low voltage electrical charges across microscopically thin coating on surface. So you'll see coming up here, there's actually dressing rooms. Yeah, right here. So you see that you walk in and you can see through them, but then you push a switch or something and then they go opaque right here. So that's really neat. New York Prada, of course, right? So that's cool stuff, right? By passing electricity through it, right? So look at this, like Biodome, right? So ETFE, replacement for glass needed, environmentally friendly, energy efficient, transparent, lightweight, right? So like, oh, look at this. This is see-through. Well, not see-through, but it would be translucent concrete. So this is concrete, and you can see the light. You can see through it. It's amazing. Translucent concrete made of glass and polymer synthetics. This is being made possible by embedding an array of tiny glass fibers with concrete blocks. It's amazing, right? Like, absolutely amazing. I'm very curious of this, and when we build our house, I'm definitely going to use this product. I think it's a fantastic product, and I've been looking at it for years now. I'm definitely going to use it in our house. So yeah, oh, these are the sunshades. So this material called Eyelight was, oh my God, I hate that. Was created specifically for the Italian pavilion at the 2010 World Expo in Shanghai. Wow, that's it. Ital Cementi's creation was made with a proprietary mixture of cement and admixtures that bonds with thermoplastic polymer resin. The resin is injected into tiny holes that span the width of each cement panel, resulting in approximately 20% transparency. The transparency can be changed by modifying the amount of resin in the panels. So it's like a concrete polymer type of mixture, right? Let's see if there's an overall, I don't know, lightweights. Yeah, look at these guys here. This is a long time ago, but this is amazing. Shoot, what's this building called again? The Hertz Corporation's global. Oh, it is Hertz Corporation's global headquarters. Okay, so this building design is really neat. See the diamond shape iron? There's no vertical structure in this entire building, they said. So true a pioneer in environmental sustainability, having been declared the first green office building in New York. Yeah, it's amazing. So there's a few pages on this, on the construction of this, but like, look at the iron, right? I think that's fantastic. So they used I think 40% less iron, 40% less, I think. Let's see here. Thus reviews strategy angle. Yeah, it does look like a jewel. I'm sure it said somewhere here. Yeah, so the triangular frames carry the gravity load and has inherent strength to and resistance to the lateral load, seismic and wind. The triangles are so efficient in terms of bearing both the gravity and lateral loads. The building used 21% less steel. So that's 9,500 metric tons of steel, right? That's a lot of steel that they used. I think that's incredible. I honestly, I think that's amazing, right? So not only are we changing the materials for sustainable building, but the methods, obviously. This is a definite method, right? So that's awesome. That's using your brain, right? Like, I really, you know, I love that, you know, the more we start thinking like, you know, management, like I've been teaching you guys, I've been telling you guys, like, you start thinking like designers and owners and managers. You know, we need to have more input. I think there needs to be more brains on how we do things, right? On our processes and our procedures and stuff like that in the field, right? The more we have guys that can think like that in the field, and the better, the more feedback and assistance we can get in developing new procedures and stuff like that, right? So I think it's amazing, right? So I'm not going to go through all this, but you guys can do it anytime. It's pretty cool. The different glass, like what's the Millennium Tower, Glasgow. The entire structure is mounted on a turntable and a bearing ring that tapers to fit. A single 300mm stainless steel bearing, which allows it to turn towards the wind like a sailboat. Oh, neat. Well, that's neat. Look at, wow, that's beautiful. So ETFE, ethylene tetrafluoroethylene. Interesting. So ETFE, a fluorine-based plastic, was designed to have high corrosion resistance and strength over a wide temperature range. ETFE has a very high melting temperature, excellent chemical and high energy radiation resistance properties. So ETFE film is self-cleaning due to its non-stick surface. It is recyclable. In sheet form, as commonly employed for architecture, it is able to stretch to 3 times its length without loss of elasticity. Wow. Employing heat welding, tears can be repaired with a patch or multiple sheets assembled into larger panels. ETFE has an approximate tensile strength of 42 nano by, I don't know what, Newton or whatever per square millimeter. So anyways, it's tough, right? So resins are resistant to ultraviolet light, so you know that stuff is going to store heat better, reflect light more, and so on, right? So ETFE is a wide range of applications. Thermoplastic lining, from wiring insulation, thermoplastic lining, corrosion protection to wire covers, mold release films. One of the primary uses of ETFE, though, is in the building industry. top manufacturer, DuPont. Interesting. So example of its use is as pneumatic panels to cover the outside of the football stadium. So that's wild. I hope we can get close up. Does that? Yeah, it does give you. So look at this. Look at these panels. So they're strong, right? They're transparent, self-cleaning. But you can see where this is going. Like, this is amazing. This is like a rec center, the water cube. And the panels are used to heat the building and the pools, right? A pump connection and manifold connects each individual bubble to maintain inflation. So that's amazing. It's like inflated bubbles, right? That's amazing. 90% of the solar energy falling on the ETFE cushions is trapped within the structure, and that's used to heat the pools and interior weight. So pretty cool stuff. There's lots of stuff going on. This Biodome thing is really cool. I definitely look at this. Like, it's like a blow up structure, right? So the ETFE is like a, it's a, what is it, polymer type of thing, right? So it's very stretchy. Biomes were inspired by the moon and are constructed from the tubular steel space. Whatever. It's pretty awesome material to use than ETFE for a fantastical project like this. What better? Yeah, that's amazing. It's absolutely incredible. Oh my gosh, the Eden project. What, like, could you imagine? I'd love to go to there and see that place. The panels vary in size up to 9 meters, 30 feet across. Wow, the larger the top. Although ETFE is susceptible to punctures, these can be easily fixed with ETFE tape. That's really neat. That's really, really cool. Like, look at this biome place. Like, hey, you guys remember the movie Biodome with Pauly Shore? Look at that, beautiful. Absolutely. Can you imagine having a wedding in there? Like, wow, right? Wow, that's just beautiful. Absolutely beautiful. So yeah, it goes over the construction of this biome here. It's a pretty cool building, and there's more on it. Like, look at the size of it. It's massive in scale, right? So look. Oh no, I thought that was a Canadian flag right here. But no, I wanted to bring you guys this material because I just thought it was amazing and beautiful, fascinating. Because, today's issue on high-tech building materials, new building materials, the high-tech 2018 edition. We're going to be seeing stuff like this, like look what we got coming up. Okay, so photovoltaic systems for the houses of the future. I picked this because I don't normally do residential stuff, but this is going to transfer over to commercial and industrial in no time. So following California's new mandate requiring solar powered systems for residential construction, so on May 9th, California Energy Commission voted unanimously to require all new homes to be solar power effective January 1st, 2020, right? So California, good on you. You guys are leaders, and we should all take your example and do the same. I love this. So if they had to be solar power, well, let's start thinking of ways to make them solar power. So these guys here have got roof shingles that look like roof shingles, and they're solar panels, right? It's amazing. That would be amazing. Plus, I hate the look of shingles. I really hate roofing shingles. So if they can make them look better, like in any way, that would be awesome. So these got these solar power sunshades, right? It's window glazing. So yeah, we're gonna start seeing more of that, right? Solar power panel, like solar type panels or panels that absorb light energy, right? And can transfer them, store them, take the direct current and store it, and then convert it to altered current, and we have power for our stuff, right? Our houses, our lights, and appliances, right? But you can see like all of these different like cladding. So this is the Copenhagen International School in Nordhave. Nordhaven, designed by Danish architect C.F. Muller, utilizes a similarly modular system of colored PV panels on its facade based on technology developed by the École Polytech Fédérale de Lausanne, EPFL. The 12,000 modules deliver an estimated 300 megawatts of electricity and collectively comprise the largest solar facade in the world. That's amazing, right? So look at that. Like, so they got solar panels in their cladding, right? So this is really awesome, man. So other emerging technologies represent the fringe of solar power surfacing. Diescrete is an energy harvesting concrete coated with dye sensitized solar cells, light reactive dyes held in suspension that deliver power to oxide electrodes. Another case is a spray-based application of nanoparticle solar cells developed by researchers at the University of Alberta. Yo, that's where I am, Edmonton, Alberta. So, like, look at this stuff. Like, oh my god, that's amazing. Like, concrete and like some kind of spray material that has solar particles in it. That's incredible, right? Now this is really neat. This superwood is what we call superwood. All right, this is okay. So anyway, so superwood. This is a wicked. Okay, so it's still wood. All right, so same wood, but what this process does with it is it takes out let me see here. Engineers at the University of Maryland's A. James Clark School of Engineering has discovered a process that can make wood stronger than steel or titanium alloys. The method begins by removing the wood's lining, the part that gives wood its color and rigidity, via boiling the material in an aqueous mixture of sodium hydroxide and sodium sulfate. That's what I couldn't really think of right there. The remaining wood panel is then compressed at 150 F, whatever that is, in order to collapse the cell wall and rid the material of weak points. The process also allows for tight hydrogen bonds to be formed, furthering strengthening the wood. This kind of wood could be used in cars, airplanes, buildings, any application where steel is used. Amazing. So this here, this is natural wood at the top. This is monolayer densified wood. This is laminated densified wood. All right, so they're gonna shoot like a rod through it. So just check this out. It's 23 seconds. Check it out. Boom. See that? Pretty neat, eh? Pretty neat. There's Dan, my man. Make sure you guys check him out. If you're a creator, Dan Courier over at Creator Fundamentals has been very helpful to me. So if you're a creator, he's a good resource for you. And this is Sean. He's pretty cool too. So anyway, so yeah, I thought that was amazing. Highly durable graphene uses a single layer of carbon atoms in both superconductor into both a superconductor and insulator by layering 2 honeycomb sheets of the 2D material at different angles. So there's nothing, you know, the wood. This wood is incredible. It's super strong. What an idea! Of course, right? Take it all apart and, or, you know, take all the stuff, you know, the weak parts out and compress it. It's awesome. This is just an article I wanted to show you on the sustainable designs, like the eco-green type of buildings that we're starting to see more and more all over the world pop up. So this is high-tech architectural style. Yeah, of course. So where is this? Which is also late modernism. Yeah, which is also known as late modernism. Okay. So yeah, I just look at this. It's a beautiful building, right? Key features of high-tech architectural style: steel and glass, flexible interiors, express construction, color used for pipework and services, lightweight materials, modern architecture design elements, stadium architecture and design, contemporary architecture of science building. So there's definitely more links in this page. Yeah, really. So here's some fine examples. You guys can go over and look at them as you, whatever you want. So representatives of high-tech architecture are Norman Foster, blah blah blah. It's these pictures that I wanted to show you, right? So this is that art gallery, and it's at Copenhagen, I think. But look at this, beautiful. This looks like something that we actually just built here in Edmonton too. We just built like a rec center that looks like this. It's just beautiful, absolutely beautiful. But yeah, it's these pictures is why I picked this article to finish off our live stream today, just to show you like look. This is the type of green roof with the solar panels in the center here. This is the type of stuff that we're gonna be seeing more of. People get to utilize our space more. So yeah, you know, rooftops are traditionally unoccupied, or space that we don't go. But employee break time, stuff like that, it's so nice to have a garden on the roof. This building, look, to die for. Look how beautiful that is, right? Could you imagine seeing, like, if all our buildings had green and, like, oh my goodness, like, how cool is that? This is the future, guys. This is the future, right? So we definitely need to, you know, like, look at this grass roof again. It's beautiful, beautiful. It's like a waterfall or something in the middle there or something. Could you imagine if this is like just like a water, like a recycle, like, you know, just go around and around, pump back in. But if this roof was constantly, you know, the water dripping and then dripping down the middle, that's awesome, right? It's beautiful. So yeah, see this stairway up to the top. I think that's obviously got to be a stadium or something. But like, look at this. This is the future, man. Like, and I love the green. I love seeing the green. So it's just so beautiful, and you know, it just smells better. The air, everything is better. You know, when you have the trees and the greenery, right? Oh, this is just my favorite thing ever. I love it. Right. So anyways, I wanted to show you guys this article as well. Because of the new style, and of course, you know, green roofs like this, definitely new materials, and you know, definitely new materials are going to arise for all of these types of buildings, right? Like, you got to be able to sustain the vegetation in the building, right? So it's so beautiful. We have a art gallery of Alberta, the AGO. The new AGO has the same panels on it. And it's curved like this and stuff. It's pretty cool. But make sure you guys check out my video on the AGO. Oh, that one, I have to do a new one. Sorry, but I will do a new one. My AGO video was taken down by YouTube because of some branding issues. But yeah. So anyways, this last page here is just a bonus page. I'm not going to go into it. It's for any of you investors out there who are watching. This is definitely, this is the market research that you want to know. All the charts are in it. So simple as that, right? You guys know what this is. So it's got all your charts and tables on in it, so it's very, very cool. But yeah, so I just, you know, ChrisKonkleVlogs is about bringing you resources, and that's what I'm hoping to do. So I hope you guys are enjoying the links that I'm providing. I know you guys are mostly watching on the replay, which is great. I might consider changing my live stream time of day. I'm doing it at, like, I started doing it 7:30 a.m. Mountain Standard Time, but most of my viewers are down in Texas and California, so I'm probably gonna go at 8 to 8:30 now, so that it's not so early for them. I'm also getting a lot of traffic from Germany, so I gotta figure out the time zone over there and take that into consideration as well. But I wanted to thank all of you for watching. This has been my 4th live stream now, every Sunday morning. between 7:30 and 8:30, we'll say for now. I'm sure it won't be any later than 8:30. Reason being is I'd like to get the stream in and done if I could before all the kids wake up, because it's still quiet. Right, so in another hour this place isn't going to be very quiet, so I'd like to get the live stream done. I don't think there's anyone in the chat today, so not yet anyways. I just just let me know down in the comments what you think of these new materials. Let us know in the comments if you have indeed used the materials. Let us know in the comments any ideas you have for the future in sustainable green building. All right, don't forget to subscribe. Hit the bell notification icon so you'll be notified of future live streams. I'll start scheduling them, so YouTube will put out notifications for when I'm streaming, and I'm gonna start streaming twice a week soon. But like I said, I got my video studio built and set up, and now I'm building and setting up my live stream studio. So I got some stuff on the way. So next week's live stream is going to be a lot different. I actually might do an impromptu live stream in between now and then, just to show you guys this new setup I have. And yeah, I want to do some more live streaming, because this is a community I'm trying to build, not just a channel that people come to watch video. I want to engage. I want people to I want it to be an engaging type of channel, right? So, yeah, reach out, you guys. Let us know in the comments what you think. Let us know what materials you have used, what materials you're looking forward to using, and any new materials you might have for us that we do not know of or have not heard of yet. If you're new to ChrisKonkleVlogs, make sure you hit that subscribe button and bell notification icon. If you're a returning subscriber, thanks for coming back. You guys are the greatest. This is Chris. Bye for now, everyone.